welcome to the Dynamics Talks. It's a global meetup series featuring tech talks on technologies presented by experts of our locations. So thank you for listening today. And I'm just dropping to the event itself, and we've got two awesome speakers today. There will be Max Karpov and Alexey Ganulin. So I'd like to introduce you the first one, Max Karpov, our senior UI developer, who will start a knowledge session on Electron and HTTP server, plus HyperDrive, plus UI, using the Git Activity Tracker as an example. Please ask all your questions in QA section in chat. You also can raise a hand and we'll unmute you. Hello, Max. Are you ready?
Hello.
So perfect. Let's get started.
Okay. I hope that everything is okay. You can see me?
Yep.
Just a moment. I need to share the screen. Okay, do you see it?
Yep.
Okay. So first of all, my name is Maxim Karpov, and I'm a developer in Grid Dynamics. And here I want to share you my experience about developing a desktop web application in short time. So first, let's talk about technologies. Who have worked with Electron? You can type in the chat. And who have worked with Express.js? And who have worked with HyperDrive? So I see that nobody haven't tried to combine all these technologies together. So then you can find how to solve your ideas and create a highly innovative desktop applications. This will be the speak about. So I want to tell you a short story about developing our application and what usually requirements we had. But first, I want to introduce you our application actually. So what is Git Activity Tracker? This tool allows to visualize Git history activity over time between users, teams, and repositories. The history and motivation was pretty simple. We were looking for an application that could analyze multiple Git repositories and help visualize the progress and the activity made by developers and different teams. The idea was to use stats and logs from Git to visualize them in a calendar chats, in graphs, which could improve our project's workflow and find weaknesses in our projects. Unfortunately, we failed to find anything like this. So we decided to make our own tool. Therefore, we have come to the requirements. You can see them on the screen. Desktop application, it should be. We support Windows, OS 6, and Linux. It has a limited access for different users because we have some restrictions in different repositories. And not all users have the strict access to specific repositories, but we need to grab the stats from them. This should have a web interface because some of the users don't want to install the application, and we can just share the web interface, allowing the others to manipulate and to check the stats. It should have a scheduler job for getting Git history, avoiding the problem when the user has to click manually on the button to refresh the stats. And it should have a dashboard interface, like with plots, with graphs, with tables, and so on. The first screenshot represents the dashboard page. There are donut charts and favorites at the bottom. When we open a repository or a entity where we can see different types of charts, such as lines, bars, calendar, dots, it's pretty useful, right? Manually, the program focuses on calendar charts, and we can check all personal stats that belongs to the entities. If we open the configuration page, we can find that there are shared settings across the devices. So everything that you can see on the preferences page, I mean, the preferences configuration page, it is shared. If you share the same application configuration across the other devices, we will speak further about that. The final setting page contains all the configuration properties, such as public key and shared key, also turn on and turn off shared drive, and Amazon S3 cloud synchronization. If you need to implement additional cloud drives like Google Drive, you can add it as a feature, but now we have focused only on Amazon S3 drive. I will show it to you how to do that actually. So here, actually, we can run a web server inside ElectronJS. You can see it here, start a web server. You can specify the host name and the port. And ElectronJS runs inside the Express. Sorry. Express.js runs inside ElectronJS. We can replicate the shared drive to all other machines, even to S3 Cloud. You can see them at the bottom of the screenshot. And we can protect the drive with a pair of public key and secret key. We see them in the middle of the screen. Drive public key and drive secret key. And the coolest thing, yeah, we can do everything and configure everything on the one page. Sorry. Development. So I want to start with a theory structure about the paradigm that we try to keep all the time when we develop applications, right? Simplicity is good, but it makes the program inflexible, as well as complexity. Slows down the understanding, and so that is why we don't have the universal answer of how to develop programs. I guess nobody has. I have divided the talk into two parts, the front-end development and the back-end development. The front-end development. The standard procedure is to collect requirements, make the concept, development, bug fixing and release, means the maintaining way. And we have technologies following to our preferences. Like we use React plus MobX. These are just my personal favorites, taste. And the Tailwind CSS and the Google Charts. I guess some you have experience working with it. The concept contained the basic dashboard page, which had to be readable. The main accent remains with plots and graphs, so we tried different plot frameworks and stopped with the Google Charts. So why React.js? First of all, it is simple, and comparing to other frameworks, has the biggest community and a community packet library. So additional pros is that it is for us takes less effort to develop a prototype. I know this can be flexible for person to person. Why Tailwind CSS? It is a relatively new CSS framework but it has a nice feature of being flexible and simple. So this is just an example that I have taken from the one of the companies that I Googled in the internet. And you can recreate the same same terminal style that is displayed at the bottom of the page, and with the simple CSS syntaxes, and change the styles whatever you want. Highly flexible. So why Mobix? As well as Tailwind, it is flexible and simple. Here's an example from the project that explains the main idea. We create a context. In other words, it is a service that we inject in any place of the program, but we can change the variables inside the model, and all the components will be re-rendered, because under the hood, Mobix model is an observable, right? So it economizes a lot of time for us. That's why it just speeds up the process of developing. Let's speak about backend development, which can be sometimes more interesting even for us. UI developers, I mean. Core requirements. So there are two crucial questions to be answered. How to communicate between different parts of our application, and how to store data in our application, because previously we had a requirement to share our stats and the configuration across devices in the network. Here is the backend stack. We have ElectronJS, ExpressJS, and HyperDrive. So let's dive deep into the details. And on the screen, we can just relatively find the correlations between them. The simple explanation of what Electron is, it is a Node.js framework that allows to write desktop applications. But it also has two things inside, a backend and the front end. And the front end runs in Chromium, so it is a browser. But backend runs as a Node.js script. But let's look at ExpressJS. This is a highly interesting, flexible, and easy to use HTTP server, or HTTPS if you use it, which contains only backend part with multiple useful features for web server development. So both can be used with sockets, right? This picture represents how sockets work. Machines communicate between each other using open ports in the network, and then send their messages in this communication channel, which is in the middle. My explanation is superficial, but I want to know, I don't want to know the details right here, right? Because you can follow a link that will be in description after the meeting and find out what it is actually and read more about it. But here we come to a bus design pattern. It is a simple user case when we send an event to the bus, and all the listeners can catch it and check the content. Then all the subscribers or participants can put new messages or events to the bus, and all the listeners can catch them and do what they want, actually. So I like that pattern a lot. And that's why this design pattern is being used in this project. And there is a real world example from the project. We have a handle event, right? We can handle it here. This is the left part. We can invoke event, the right part. And we can also send events to the bus, and we can catch events. And the coolest thing that all these things work in the browser, work in the backend, work in ElectronJS and in Express.js. So it's isomorphic code, in other words. And it actually uses sockets. So we can answer on the first question of how to communicate. So we can use socket and Express.js with ElectronJS. The next question is how to store data. So there are requirements. The first thing, it should be versioned. So we have different versions of a file, and we have to be able to switch between versions, because if we share across the network, we need to understand what version we have to synchronize. And it should be local also. In other cases, if we turn off the internet connection, it should work. It should be fault tolerance. It means that if we cut our internet connection on the half of the synchronization process, it should continue be working. And when we restore the connection, it should be resynchronized. It should be remote. So it means that if we haven't initialized the local repository, it means that we have to grab it from the internet. So we tried to choose between a server-based drive like Amazon S3, Google Cloud Drive, and others. And we compared it with the peer-to-peer drives like HyperDrive. That is actually a simple explanation of it. It simulates a torrent protocol, but it has its own protocol version. So alternatives are presented on this slide, such as Amazon S3, Microsoft OneDrive, Google Cloud Drive, Dropbox, and on the right side we have the alternatives for peer-to-peer drives. Like we have chosen the HyperDrive plus HyperSwarm, and I will explain it a little bit later about it. And Apple ShareDrop. So Apple ShareDrop, if you didn't know that, it is a peer-to-peer protocol. And that is a new connection, and you can read about it. It's very interesting. It tries to change our internet completely. Internet and WebTorrent, I guess you know that, and IPFS. IPFS, this is the another version of HyperDrive, but unfortunately, it doesn't have a lot of features like HyperDrive has, because it's not so flexible. So what is peer-to-peer, you may ask? There is a simple image that shows the main feature. It allows to create a non-centralized network structure using socket transport protocol or some variations that may replace with something else. So the key point that it is decentralized, it is auto-scalable, and it is unlimited because we don't rely on simple servers. More peers we have for users, faster and reliable the internet is, the connection is. So, and here we come to peer-to-peer swarm connections. This is like a theory. This is a feature that shows up when we maintain such networks. In most of the cases, we will have a distributed structure with which you can see at the very right of the screen. There are three structures. Because all of the peers have one or more connections in the network, it means that it actually makes it reliable. And in some cases, we may have closed networks where we can divide the network into clusters. It actually being divided automatically. So only a few of the peers can share the changes to the rest of the outside of the network. which is really cool, actually. So to create this structure, we offered to use the simple solution. This is HyperDrive plus HyperSwarm. HyperSwarm is a high level of API for finding and connecting to peers who are interested in a topic. So it means that the previous slide represents that kind of swarm where it creates automatically. Using HyperDrive, you can share whatever you want across the network. HyperDrive is secure and reliable distributed file system designed for easy peer-to-peer file sharing. This is the simple example from their documentation. So you can write, you can read files, you can delete files as well. HyperDrive can be easily replicated over the network, but not at the swarm. You can replicate it from peer to another peer. So you have a strict connection, socket connection or something, or pooling. And you can use it with a swarm. This is the real life example. I have taken it from the code, from the project. At the left of the screen, we take that data from the bus. Then we check the public key and the secret key. Then we run the HyperSwarm and pump socket messages through the opened connections. So at the right of the screen, you see that we have a swarm. And when we connect to a peer in the swarm, we pump the connection. We use the simple library pump that actually pumps back and forward and backward the connection stream across the peers. Very useful, actually. And you can create peer-to-peer drives across the network. So easy. And if you want, you can additionally add the S3 cloud, Amazon S3 cloud, or Google Cloud, or something else, just doing the same thing. There are lots of libraries to do that, actually, instead of you. And the downtake from this is that we can make a non-centralized file sharing across the world, even inside the protected networks. And we don't have servers. So the last question was how to store data. And the answer is we can use HyperDrive and HyperSwarm using a peer-to-peer protocol, right? The first question was how to communicate is to use ElectronJS and ExpressJS using socket and the bus design pattern. So actually, we have solved all the questions. Overall, this project allows you to track and visualize Git activities for various repositories, users, teams, and projects. And I hope this talk was useful for you, and you will make something cool with it and with the knowledge and the experience that I have shared. I believe that it may motivate you to experiment with different technologies and always being in searching for better solutions. And before finishing it, I want to show you the demo. For example, if I open, I have to reshare the screen. Okay. Then I have to open the Git Activity Tracker. It loads. And this is actually the application that we have developed. I have analyzed my simple repositories that I developed some months ago, and a React repository. So as you see, that stats has been taken today, and today they have made some changes here. These are just points. They are not actually represents your work or the activity that you have made, because there is a formula that you can correct, and it may be dependent on your project, and it actually can be flexible if you want to do that. So, for example, if we open the React JS repository, we can understand who is the most valuable developer in this repository. This is obvious. This is Dan Abramov. We can find the messages. We can turn this feature off to collect the messages, actually. We can check the specific date where the development was the highly efficient. We can check, for example, for last 2 years stats. Yep, it loads. Has been loaded. And all the years are in the screen. And we can also print it. So I like Tailwind CSS because it allows to make the printing mechanism pretty much easy. This is another discussion in another talk. We have favorites. We can turn the last 2 years, for example, to the last 6 months and check the stats. We have configuration page here, where we can configure the users here. We can add them as well. So you can register them. You can change the repositories. You can create teams, divide people into 2 teams or more. And you can set the settings here, where you can configure what you want actually to don't collect statistics locally and to create a server-only solution, run a web server, and so on. And you can check logs as well. So I guess I can finish with it. So.
Okay, thank you, Max.
Thank you. If you need to contact us, so this is the screen.
Yeah, I'll post here 1 minute of Q&A session. And we'll wait until any participant will write here question or raise a hand. In this time, I should ask you just one question from my side. Just trying to be a devil's advocate here a bit. Let's suppose that I'm Dan Abramov. So what exactly I can get from this report? I mean, from the perspective of being the first one in the repository.
It means that in some cases, if somebody would say that we can offer you another project to develop, you can find, or you can show the stats that you're the most valuable person in the current project, so you shouldn't be moved on. So there's lots of scenarios how you can use that. But my idea was to develop the application, actually.
Okay, got it. So yeah, I'm supposing that if I'm Dan Abramov, I can just create my own Patreon account for all the funds, let's say, for donations. Right?
Yeah, and even though, so we can find where Dan Abramov didn't work.
Yeah, we can always punish him.
So do you have some questions? Put them in the chat below. There is one hand here.
Yeah, okay. Victor, you can talk.
All right. Hello. So, if I'm correct, you have chosen the peer-to-peer protocol because of the cost?
Yeah, because we have developed it for the secure environment at first. We didn't have servers at all. We just had to share the stats. We didn't have the shared folder. We didn't have the access to create a server, but we had to share the stats with the other participants and the other members of the team.
Okay, thank you.
So if nobody has questions, I can turn off.
Yeah, seems like. Thank you, Max.